When you first receive your operant interfaces, start by installing them into your operant cabinets. Plug in each component, such as levers, lights, etc., into the input and output ports. As you do this, I recommend making a list of what's connected to each numbered port. This will make things much easier when you go to configure the interfaces later on. Next, plug in each interface into the computer using the USB cable provided. Then connect the interfaces to power. If you purchased the L or C interface, then you'll have received a 28-volt power brick which plugs into the very top of the interface. The M interface, on the other hand, can either be powered from a 28-volt power brick, if you purchased one, or from your existing MedAssociates 28-volt power source. With everything wired up now, open ANY-maze and go to the I/O page. This is where we'll configure and test the hardware. You should see all of your operant cages listed on the left. They will be automatically numbered, but they may not be in the correct order. For example, the interface called operant cage 7 might actually be in your operant cage 1. So, to renumber them, select one of the interfaces and click Renumber All. Then follow the on-screen prompts, pressing the red button on top of each interface in the order in which you want them numbered. Start at what you'd call operant cage 1 and press the button on the interface installed in that cabinet. Then cage 2, then cage 3, etc. After this, if you want to confirm the numbering went okay, click on an interface and select Identify this device, and the green LED will blink on that interface. Next, grab that sheet of paper you made earlier with each port assignment, and we're going to configure the ports in ANY-maze. Select one of the interfaces on the left and click Configure this device. You can add your components in any order, it doesn't matter. You can find the item yourself, or type in the name or product code in this search bar. We have a whole library of existing product codes. Then select the port that the component is connected to. You can optionally rename this component as well. For example, differentiating the left lever from the right lever. Then add the rest of your components. If you don't see a component listed, please contact us at support@anymaze.com with the details, and we can help determine if this component is compatible with your interface. Most likely it is, so do reach out. Once all the components have been added, you can copy the configuration to the rest of your interfaces like this. Quick and easy. You can test that each component is making a connection by activating the inputs in your operant boxes, such as pressing a lever. Then confirm that the input is illuminated green in ANY-maze. Next, check the outputs by activating them from ANY-maze. Simply click a square for an output and confirm the output has turned on in your operant box. This might take 2 people to do. Once you're happy with that, let's move on to set up the protocol. Start by putting the protocol into operant mode. Then add an apparatus and select the operant interfaces you want to include. You'll be asked to configure the interfaces, but you've already done that part. So click Finish, and ANY-maze will have added each component to the protocol for you. I want to briefly outline the anatomy of the protocol page at this stage, just so you can understand what you're seeing. You have your apparatus items, which represent each physical operant box. Then the I/O devices are the interfaces themselves. Then below that, we have each component listed and the details of operation within those. For example, a specific output duration or light level. Now there's not much left to set up, so let's add the stages of the experiment. If you haven't seen our intro video, stages are the various phases of an experiment. For example, you might have a habituation stage, followed by a training stage, followed by a testing stage. These occur as separate tests, and you can include repeated trials within each stage. Trials, by the way, are individual tests. They are not repeated exposures within a single test. I just want to clarify that terminology since it varies between disciplines. By the way, if you find this terminology confusing, you can feel free to change it over here. The final protocol item you need to set up is procedures. This is really the crux of it all. When to turn on the tones, how to respond to lever presses, etc. It's our version of med state notation and coding. But don't worry, it's very user-friendly. In fact, we modeled this after a software that is used to teach children how to code. In this example, I want to turn the stimulus light on and off every 10 seconds. Then, when the animal presses the lever while the light is on, he'll receive a shock, and when he presses while the light is off, this will be reinforced with the sucrose pellet. We can simplify this by writing two separate procedures, one for the light turning on and off, and one to process the lever press contingencies. The two procedures will then be performed in parallel during the test. Let's give the first procedure a name, then select which stages it should apply to. So I'll remove it from the habituation stage, in which no outputs are activating. To build the procedure, we'll click and drag these colored statements into the white space on the right, and ANY-maze will read it from top to bottom. Let's first have ANY-maze wait for 10 seconds, then turn on the stimulus light. Then wait another 10 seconds and turn it off. We'll have this repeat indefinitely. The test will end when the test duration is reached, which you will have specified under stages just a minute ago. Then we'll add the second procedure to process lever presses. First, ANY-maze will wait until the lever is activated, meaning the animal pressed it. Then we want the procedure to assess whether the light was on at the time of the press. If it was, activate the shocker. Otherwise, dispense a pellet. This will also repeat indefinitely until the test ends. Now this is just extra, but we can also add charts to the protocol so we can visually see the activity occurring in each cage while the tests are running. Just add the event that you want charted. Then we can specify that we want it displayed during the test. Let's add a chart for each I/O item. Then we'll add the stimulus light as a state channel, which means it'll be shown on the same graph as the main I/O item. This will make a bit more sense in a minute when we run a couple of tests. I will show you what that looks like. Okay, I've gone ahead and added my treatment groups and animals, so let's move on to the test page. I'll just rearrange some panels here so my charts are front and center. These are your panels down here, and you can promote any one of them to occupy the top space like this. Skipping forward, I've run all of my habituation tests because there was nothing going on during those tests, so nothing to show. So now we're ready to start the training. I'll just start my tests, and the animals will do their thing.
These are the state channels I mentioned earlier, which show the stimulus light activation. You can see that our procedures are working. This animal pressed the lever while the light was on, and so he received a shock.
Let's now take a quick look at some of our results so far. Let's graph the number of shocker activations grouped by treatment to see if our control animals learn the task better than the treated animals. And we'll also filter to show only the training trial. This results page will update as we run more tests, so you can stay updated on your results in real time in a matter of seconds. This is probably the most powerful feature of using ANY-maze for your operant experiments. Unlike other platforms, you don't need to spend time exporting your data, running some crazy macros in Excel every day just to view your progress, including running stats. You can do that in ANY-maze. Now, before we wrap up, I wanted to point out another useful feature for operant experiments called test segments, or what you might call time bins. Let's bin our data in, say, 20-second segments. We can then graph the shocker activations across the 20-second segment like this. You'll also notice I was able to do this even after I've performed my tests. In fact, most protocol items can be changed retrospectively. And I'll just quickly show you how you can include the test segments, aka time bins, in your spreadsheet for exporting as well.
Just select the measures you want to include in the spreadsheet and apply any filters you want. Let's just include the first training trial here. Then, let's add a column for the test segments. Now reviewing the spreadsheet, you can see that each test is segmented into 20-second bins.
If you have any questions about your setup, please email them to support@anymaze.com and we'll be very happy to help you.